Hello everyone, I'm Vashni from Seder Institute of Technology, studying BA Computer Science and Engineering. I'm going to take a topic on support vector mission. In agenda, there are three ways, types of SVM. SVM is called as support vector mission. Then hyperplane and support vector in a SVM algorithm. Then how does SVM works? Now we are going to see the topic on support vector mission and define the support vector mission. Support vector missions or a SVM is one of the most popular supervised learning algorithm which is used for classification as well as regression problems. However, primarily it is used for classification problems in the machine learning. The goal of the SVM algorithm is to create the best line or a decision boundary that can be segregate n-dimensional space into a classes so that we can easily put the new data point in the correct category in the future. This best decision boundary is called as hyperplane. SVM choose the extreme points or vectors that can help in creating the hyperplane. These extreme cases are called as support vectors and hence algorithm is termed as a support vector mission. Consider the below diagram in which there are two different categories that are classified in using a decision boundary or a hyperplane. These are the images that we are using as a x1 and x2 as a margin, and there is a maximum margin hyperplane and the negative hyperplane. The green dots are called as support vector, and the dotted lines are called as positive hyperplane and the margin maximum. And now we are going to see an example in SVM. SVM can be understood with the example that we have used in a KNN classifier. Suppose we see a straight cat that also has some features of dogs. So if we want a model that actually identify whether it is a cat or a dog. So such a model can be created by using a SVM algorithm. We will first train our model with a lot of images of cat and dogs so that it can be learn about the different features of cat and dogs, and then we will test it with the straight categories. So as a support vector, creators a decision boundary between these two data and choose extreme support vectors. It will be see the extreme case of a cat and dogs. On the basis of a support vector, it will classify a cat. In SVM algorithm, we can use for a face reduction, image classification, and text categorize, etc. Next, we are going to see about the type of SVM. SVM can be of two types, that is a linear SVM and the non-linear SVM. Linear SVM means it is used for a linearly separatable data, which means if a data set can be classified into two classes by using a single straight line, then such data is termed as a linear separatable data, and the classifier used is called as linear SVM classifier. The nonlinear SVM is used for a non-linearly separated data, which means of a data set can be classified as using a straight line, and such data is termed as a non-linear data, and classifiers used is called as non-linear SVM classifier. Next is going to see about hyperplane and the support vector in the SVM algorithm. In hyperplane, there can be a multiple lines or a decision boundaries to segregate the classes in n-dimensional space, but we need to find out the best decision boundary that helps to classify the data points. The best boundary is known as a hyperplane of SVM. The dimensions of a hyperplane depends on the features present in the data set, which means there is a two features, that a hyperplane will be a straight line and there will be three features. The hyperplane will be a two-dimensional plane. We always create a hyperplane that has a maximum margin, which means the maximum distance between the data points. Next, we are going to see about support vector. The data points are a vector that are closest to the hyperplane and which affects the position of a hyperplane are termed as a support vector. Hence, these vectors supports a hyperplane. Hence, is called a support vector. Next, we are going to see about how does the SVM works. In linear SVM, the work of a SVM algorithm can be understood by using an example. Suppose we have a data set has a tags, green and blue, and the data set has a two features x1 and x2. We want a classifier that can be classified the pair x1 and x2 of coordinates in each green and blue. Consider the following diagram below. So, as it is two-dimensional space, so by just using a straight line, we can easily separate these two classes. But there are the multiple lines that can be separated by these classes. Hence, the SVM algorithm helps to find the best line or a decision boundary. These best boundaries or a region is called as hyperplane. SVM algorithm finds the closest point of the line from the both classes. These points are called as support vectors. The distance between the vector and the hyperplane is called as margin. And the goal of SVM is to maximize the margin. The hyperplane with the maximum margin is also called as optimal hyperplane. Next, we are going to see about nonlinear SVM. Nonlinear SVM. If a data is linear arranged, if a data is linearly arranged, then we separate it by using a straight line. But for a nonlinear data, we can't draw a single straight line. Consider the following diagram. So, to separate these data points, we need to add one more dimension. For a linear data, we have used two-dimensional x and y. So, if for non-linear data, we have to use a three-dimensional z. It can be calculated as z is equal to x square plus y square. By adding the third dimension, the sample space will become as this given image. So now SVM will be divided as a data set into a class following way. Since we are three-dimensional space, hence it is looking for a like a panel parallel to the x-axis. If we can convert it to two-dimensional space with z is equal to 1, then it will become as a best hyperplane. Hence we get the conference of a radius 1 and a case of nonlinear data. Thank you.